All right, today we're going to look at the relationship between circles and tangents. A tangent line intersects a circle at exactly one point. So if we look over here at this picture, see that point A? That line is touching the circle at one point on the circle. A line is tangent to a circle if and only if it is perpendicular. You guys remember what perpendicular means? Perpendicular, a shortcut symbol for perpendicular would be this right here. It's when a line hits another line at a 90-degree angle. And a line is tangent to a circle if it's perpendicular to a point drawn to the point of tangency. So, yeah, so there's the basic definition for it. So just to illustrate that, if I have a circle and I have a line, if that line is perpendicular to the radius at this point where it touches the circle, then it is a tangent line. It's considered to be tangent to the circle at point A. So when we look at number 1 here, it says determine if AB is tangent to the circle P. So AB is this line here, and it is tangent if this is 90 degrees. And we can see if that's 90 degrees by seeing if this is a right triangle. So we can test if it's a right triangle if the Pythagorean theorem works out with it. So remember, the Pythagorean theorem is leg squared plus leg squared is hypotenuse squared. So when we test that out on that triangle, that would be 8 squared plus 15 squared equals 17 squared. So if this is true, then that line is tangent because that's a right triangle. And if you finished the math on this, you would find that yes, it is. It is true, so that is tangent. Okay, let's look at number 2. Do some erasing here. Number 2 is a little bit trickier because take a look at where that 5 is. And again, what we're trying to figure out is if this line AB is tangent to this circle at point A. And if it is, then this would be a right angle and this would be a right triangle. But we're missing some information. We know this is 14 and this is 11. But we don't know the hypotenuse here. And if we look at the picture, we see that the radius is 11 in this circle. So this little segment is also 11. So the hypotenuse here would be 16. Okay, so now we want to see if the Pythagorean theorem is true. 11 squared plus 14 squared is 16 squared. So we will grab a calculator. And 11 squared is 121. 14 squared is 196. And we're trying to figure out if that equals 16 squared, which is 256. So add up 121 and 196. And I can tell already it's not going to work. So that is not equal. So this one's a big no. It is not tangent. This does not make a 90-degree angle. And we go about our day. Okay? All right. So you thought you would think that a yes or no question is easy, but look at the math that we did for this. Because we have to justify our answers. We can't just guess yes or no. We have to do the work to make sure we're right. Okay. More tangent line properties. If two segments from the same external point, so in this drawing here, this would be the external point B, are tangent to a circle, then they are congruent. So when you have some point out here, and you have tangent lines intersecting at that point, these line segments are congruent. Now, how can we tell that AB and CB are tangents? Well, we know for sure because of the right angle they're making at the point of tangency. They're perpendicular. And then this one, I don't know how much you'll use this second one, but it says if a polygon is circumscribed around a circle, then all sides are tangent. Okay, and this makes sense because circumscribed does mean like you're coming in contact with the circle, one point for each part of the polygon. All right, so let's try number 10. Find each value or measure. Assume that segments that appear to be tangent are tangent. So looking at this drawing, it looks like AB and CB are tangent. If they're tangent, then we can make use of this property, and that would mean that these two segments are congruent. So if those segments are congruent, they have equal measures. So we can say 5x plus 23 equals 8x minus 19. And calculate that for x. We'll subtract 5x from both sides. We'll add 19 to both sides. And we'll divide by 3. Oh, wait, hold on. Handwriting issue. 9 to, that's 12. That's a 2. That's 42, not 47. So 42 divided by 3 goes in once. So x is 14. Okay, this next one is exactly the same. We've got two line segments that are tangent to the circle, so those must be congruent. So we'll say 14x minus 13 equals 8x plus 5. Subtract 8x from both sides. Get 6x minus 13 equals 5. Add 13 to both sides. Solve for x. However, it wants PQ. And PQ is 14x minus 13. So we plug 3 in for x. That's going to be 42 minus 13. So this PQ would be 27. Whoops, that's wrong. Again, handwriting issues here. 29. Right? It's hard writing with this pen. Okay. 42 minus 13 is 29. Okay. What's on the next page? Let's find out. On this one, we need to find the length of x and we are assuming that JK is tangent to that circle, so that makes that perpendicular. Okay, so if this is 11, that radius is 11, so this hypotenuse piece of that triangle would actually be 18. So I'm going to redraw the triangle. Whoops, went too far there. This is x, that's a leg. The other leg's 11, and the hypotenuse is 18. So I'm going to use the Pythagorean theorem. Leg squared plus leg squared is hypotenuse squared. 18 squared is 324. Subtract 121 from both sides. And get 203. So x is the square root of 203. Again, I hope I'm not making handwriting issues here. 14.25. Okay, number 6. Similar idea. Looks like JK is perpendicular. JK is tangent to the circle at point J. So we've got a right triangle. This is x. Hypotenuse is 25. And on this leg here, this is a radius of 11. So this is another radius of 11. So that whole leg is 22. So we'll do leg squared plus leg squared is hypotenuse squared. Okay, so then 22 squared is 484. 25 squared is 625. Subtract 484 from 625. We get x squared is 141. So x is the square root of 141, or about 11.87-ish. Let's call it 11.9. All right, so that's it. I've got 6 problems for you to try. If you don't understand, you need to text me a remind, and I will help you understand, okay? I cannot help you unless you ask me questions or tell me you need help. All right? Have a great day. Bye.